In this video, we're going to review how to find the volumes of prisms and cylinders. And remember, a prism looks like something like this, where you have two parallel sides and the faces are polygons. Okay, so they look like something like this, where a cylinder has a circular base. Okay, so whenever you have a circular base, you have a cylinder. If you have a different shape base, then it will be a prism. So the volume of a prism is V equals capital B times H, where capital B is the area of the base. So let's review how to find the base. Bases are parallel to each other. So in this triangular prism, that's really easy to determine the base, because the base, the only two parallel sides are the triangles themselves. And that's why we call this a triangular prism. Whereas in this cube or in this rectangular prism, you can see we have 6 pairs of parallel sides. So I usually choose the top and the bottom to be my base, because that just makes it easy. It just seems like it should be the base. So the volume of a cylinder has the same formula as the volume of a prism. It still is the volume of your base, okay, and here your base is circular, times the height, and the height of the prism for all of these, it's the distance, the vertical distance or the perpendicular distance between the two bases. So it's a perpendicular distance. So this is your height. Okay, so for here, the perpendicular distance would be this. For this example, the perpendicular distance would be this. Okay, so it has to be perpendicular distance between the two bases. But because my base is a circle, I know what the formula for finding the area of a circle is. It's pi r squared. So typically we use this formula right here to find the volume of a cylinder. Okay, so I'm going to walk through 8 examples which are very similar to the ones that you have on your homework. So the very first example is we need to find the volume of this rectangular prism, and our formula is BH. So let's outline our base. Again, I usually use the top and the bottom of my boxes as my bases. So this is just a rectangle. To find the area of the base, it's just length times height, or 6 times 3, which is 18. To find my volume, it's my base, which is 18, and that's feet squared, times the height, and the height here is the perpendicular distance between the two bases. So it's 3, so 3 times 18 is going to be 54 feet cubed. Remember, area is in squared dimensions, volume is now in cubed dimensions. All right, so how do you find the volume of this? Again, I'm going to choose my base to be the top and bottom of my box. So my base, the formula for my base to find that is just length times width. We have the width as 5 inches and the length is 8 inches. 5 inches times 8 inches is 40 inches squared. But then we have the height of our box, the perpendicular distance between the top and the bottom is 2. So our volume is our base, the area of our base, times our height. So this is going to be 80 inches cubed. All right, so here our prism looks a little bit different. Our bases are the parallel sides, so they are going to be our triangles. These two triangles look parallel. The other sides are not parallel. So one nice thing about this picture is that this is an isosceles triangle, so this is also 3 feet because the markings tell me they are congruent. So again, the volume of a prism is the area of the base times the height. And the base, since it's a triangle, to find the area of the base is 1/2 base times height, where little b is the base of your triangle. So that's this number here. That's the bottom of our triangle. It's 3. And our height of our triangle is the perpendicular distance, right? And I have this nice little perpendicular symbol here. So I know 3 is my height. This guy right here. So I get 9/2. So now to find the volume, all I need to do is locate the height of my prism, and that's the perpendicular distance between my bases. So I get 9/2 times 5, which is 45/2, and this is going to be feet cubed, where my base is feet squared. Okay, so here we have another triangular prism, but I want you to take a look. Our bases here are equilateral triangle. A nice equilateral triangle. So I'm going to draw that out over here, because one of the things we're missing is we're missing the height of this triangle. We have the 6 centimeters, but we don't have the height of this triangle. So how are we going to find the height of this triangle? Well, we have to drop a nice little perpendicular here. And that splits our triangle into 2 pieces, right? So I divides my base in half, 3. And I know that this is 60 degrees because it's an equilateral, so this has to be 30 degrees. So this is my short leg, so my long leg has to be 3 radical 3. So the height of my triangle is 3 radical 3. So 3 radical 3. Okay, my base is 6, my height is 3 radical 3. So the formula to find the volume is base times height. The area of the base is, since this is a triangle, 1/2 little b times h. Okay, little b in this case is the whole entire base, which is 6. The height is going to be 3 radical 3. So for my base, I have an area of, let's see, these reduce to 3, 9 radical 3. So for my volume, all I need to do is locate my height now, the height of my prism, and that's the perpendicular distance between my 2 bases, which is 18. So when I multiply 9 times 18, I get 90 and 72, so that's 162 radical 3, and that's going to be centimeters cubed, where the area of my base was centimeters squared. Okay, so again, this is our new formula, and again, it is the area of our base times our height, but our base is a circle, so the formula for a circle is pi r squared times our height. So all we really have to do is find the perpendicular height and the radius, and we have it solved. So here's, this number here, this looks like it's pointing all the way across. This is my diameter. So what is my radius going to be? Well, my radius is half of my diameter, so it's going to be 5/2. So where's my perpendicular height going to be? Well, it is not this, because that's not perpendicular. All right, but I do have something in my picture that shows me the perpendicular height. It is 6 meters. So my height is going to be 6 meters. And my radius is 5/2 meters. So now all I just have to do is plug this into my formula. Pi times my radius squared times the height, which is 6. So when I square 5/2, I square the numerator and the denominator. 25/4 times 6. And I know that 4 and 6 reduce by a factor of 2. So 3 times 25 is 75 times pi all over 2, and this is going to be meters cubed because we have volume. All right, here we go. So again, in this formula, remember, this is our base, the area of our base times our height, and our base is a circle. So the area of a circle is pi r squared h. So I need to find r. R in this case, they gave me the diameter. Okay, so I need to split that in half to find r, so it's 6 inches. And I need the height. Okay, so you can see that here's the top, here's the bottom. The perpendicular distance is 8 inches. So when I calculate, I get pi times my radius squared times 8. Okay, radius squared is 36 times 8. So 8 times 30 is 240. 8 times 6 is 48. So I get 288 pi inches cubed. Okay, so how about this one right here? This is asking us a little bit different. I want you to notice they gave us the volume here. They're asking to find the height. So this is a cylinder. So remember, the cylinder is pi r squared h. So I'm just gonna, in this formula, I'm gonna plug in everything I know. I know that the volume is 3,240 pi. I know that this is my radius, right? This is my radius because it has only outlined half of the diameter, and I know that's my radius. So I'm going to plug those two numbers in for volume and radius. So I get 3,240 pi equals pi times my radius squared times h. And now you can see that I only have one variable to solve for. So let's go ahead and multiply square our radius. And then to get h by itself, I'm just going to have to divide by 81 and pi. All right, they cancel out. All right, so my height, well, I have pi's over here that also reduce out. Okay, so I showed you a little trick before. If you add up all the digits and they're divisible, and the sum is divisible by 3, then the number is divisible by 3. So when I add these up, I get 9 and 9. So I know these answers are divisible by 3. So I'm going to take a 3 out of each one of these. Let's see. 1, 0. I made a mistake here. 3 goes into 24 8 times, and this is going to be 27. But then I add them up again, and they're also divisible by 3. So I get 360 over 9, and that reduces really nice to 40 millimeters across, distance for height. All right, and then the last one, we're going to do the same. We have a volume that equals our base times our height. So let's calculate our base area. It is going to be, since it's a triangle, 1/2 3 times 4, and this reduces nicely. That reduces to just 6 inches squared. So when I put that in my formula, I get 6 times h. I'm going to replace my volume with 72 inches cubed. And when I divide both sides by 6 to solve for h, I get h equals 12 inches. So when you're solving for the height, just bring your formula up and plug in the numbers that you know. And that's all I have. Your worksheet should be very similar to this, so if you watch this and work along with me on your worksheet, it should be fairly easy.